In this module, we will be looking at how to set up extensions, as well as how to import terrain provided by a surveyor into SketchUp. So we're going to go and jump ahead straight into the demo. The theoretical information will be provided as we go along with the tasks that we need to do. So the goal of this demo will be to import terrain provided by a surveyor and prepare it for future work. In particular, we will be looking at terrain formats and types, how to create a 3D terrain from a set of 2D lines, how to adjust that terrain, and we'll start looking at plugin types and when to use them. Alright, so let's go ahead and open up DIS1 M2 terrain provided in the demo folder. So when we open this file, we will basically see two things. First of all, we will see the Google snapshot that was imported into the file when the model was accurately geolocated. And second, we will see this municipality data, which includes all the lot boundaries, as well as the placement of the most important trees on the lot on which the demo project will be constructed. Obviously, this doesn't include all trees, as you can see here. It's a pretty dense forest, but it includes the biggest trees, so those that we will want to take into account when we will be working on landscaping. They're also divided into two kinds, so orange is birches and gray is ash trees. So a few words about Google Snapshots. When you geolocate a model inside of SketchUp, Google will automatically import two things into your model. First of all, it will import a 2D snapshot of the area viewed from a satellite. And this is what you see right now. But it will also import a 3D terrain that corresponds to that area. So if I toggle the visibility of the Google snapshot here, and I toggle the visibility of the terrain layer, if I go inside this component, you will see that this component is made out of a variety of triangles. So it's triangulated terrain. And these different points, they change in altitude. So while this is good to give us an idea of the terrain variations in a large area, it's not that great for our actual architectural use, because as you can see, the terrain, which is actually pretty big, it's maybe 15,000 square foot, so it's a pretty big terrain. So you can see that those 15,000 square feet are distributed in what appears to be approximately 12, 13 rectangles. And that doesn't really give us a good idea of the, fine variations in terrain inside here. Also, if you look down, the copyright says 2016, but the imagery from the satellite doesn't always correspond with the terrain data. Therefore, you might have a terrain that was recorded at a much earlier date than 2016. So that wouldn't take into account the more recent alterations to that terrain that we have right now. So for that reason, if you're working with a surveyor that can give you more detailed terrain data, that would be ideal. And in fact, that's what we're going to be using for the demo project. So what I'm going to do is I'm going to switch back to the snapshot, and I'm going to turn off the 3D terrain, and I'm going to delete that layer. So I'll do that by clicking on the delete layer button right here. And it's going to ask me if I want to keep the geometry that's on that layer, and since we don't want to keep that geometry, I'm going to say no. Alright, so now what we'll do is that we'll import the terrain data that was provided to us by the surveyor for this demo project. So I want to take a few moments to discuss the different formats that terrains come in. Different surveyors work in different programs to map their terrains. As far as SketchUp is concerned, the ideal formats for SketchUp to import are DWG and DXF formats. And the reason for that is because the data in those formats is stored in a uniform manner. Therefore, when they're imported into SketchUp, the chance of having mistakes and errors is minimized, which is great. There's also the .kmz format, which stores data in a uniform manner, but .kmz is used for much larger terrain swaths, so not suitable for residential architecture. At least I've never seen a surveyor give me data in .kmz for smaller projects. The other format that you might encounter is .csv. So .csv files are basically giant Excel spreadsheets with data attributed to specific points in space. And you can't import .csv files into SketchUp by default, but there are some plugins that do that. The only caveat with .csv files is that the syntax inside the files is not uniform. Therefore, you need to communicate to your surveyor that the data must be in a specific format. So that format is right now displayed on the screen. And as long as it's in that format, you'll be able to import it with a plugin called Point Gadget version 2 and make a 3D terrain out of that imported data. But ideally, DWG or DXF work best. So that's what we're going to do right now. We're going to go into File, Import, and I'm going to import DIS1 M2 terrain.dxf into this file. All right, so it tells me that it imported a bunch of lines, blocks, and layers. That's good. We're good with that. And as you can see, the terrain is made out of contours, and that's actually really great because it's going to be really easy for us to take these contours and turn them into a 3D terrain shape. Also, if we go inside, there are no additional components here, so there's only lines, and that's great too. If sometimes it happens that you import terrain and there's additional components inside the main component, in that case you would want to press X, so that's the shortcut we assigned to the explode function, to explode your terrain until there are no more components left inside. So once we've done that, we can again go inside the terrain, select everything, and then we're going to click on the Form Terrain from Contours in the Terrain Sandbox toolbar in SketchUp. So I'm going to click on that, and it's going to be working on it. There you can see the loading bar here. And yeah, this basically gives us a 3D terrain that it just formed from those contours, which is pretty cool. Now what we're going to do is we're going to select this terrain, and as you can see, the newly created terrain is on a different component yet again, which is good because we don't really want to see those lines. So what we'll do is we'll select everything again, and we'll deselect the terrain, and now we will delete the line contours by pressing delete. Alright, so what we have left is only the actual 3D terrain, which is exactly what we wanted. Now what we're going to do is we're going to try to place this 3D terrain in the middle of this corresponding square that was provided by the municipality as well as the surveyor. So to do that, we need to make some construction lines. I'm going to go to this corner here, and I'm going to make two lines. First of all, a line like this on the green axis and a line like this on the red axis. And these two, I'm not sure if they have exactly the same altitude yet. It looks like it's an intersection. All right, in that case, I'm going to zoom out. I'm going to grab everything, so the terrain and those construction lines. And I'm going to pick this intersection here and grab this whole bunch of geometry and move it into the corner of the terrain provided by the surveyor. Right here, by the municipality. Right here, and delete these construction lines. We don't need them anymore. So yeah, now our terrain is accurately located on the municipality plan. So that's it for this clip. In the next clip, we will project our municipality lot lines onto the terrain and also making small adjustments to the terrain itself.